it's important that we understand how Azure implements security across virtual networks. By default, a machine that is on one virtual network cannot communicate with a machine or a database on any other virtual network. Now, obviously, if we're dealing with storage accounts or Azure SQL database that don't exist on virtual networks, then that doesn't apply because those are public services that require a key to access. But if you've associated your storage account to a private endpoint on a virtual network, then you will find that a virtual machine on another network cannot communicate with it. But that doesn't stop the communication. We can actually set up what is called a peering relationship between the two. So if we go into one of the virtual networks and we go into peering, then we'll be able to add the connection between those two networks. So I'm going to say add. We do have to give the name of the peering connection from the one network to the other, and then we're going to also name it from the other back. So let's call this new test 1 to 2. Now we're using the resource manager model, of course. If we wanted to connect two networks that were across subscriptions, then we could use the resource ID model, and this will allow us to connect with a virtual network that we don't have access to or a subscription. We're going to connect this name here using our subscription. We're going to connect to new test 2. So we are working on new test 1 and we want to connect to new test 2. Now we do also have to create a name for the reverse connection. So this is called new test 2 to 1. Now this is where we get to configure whether we allow traffic in both directions or we only want the traffic in one direction. So allow virtual network access from 1 to 2 enabled, allow virtual network access from 2 to 1 also enabled. If I was to disable this, then all the devices on 1 can connect to devices on 2, but 2 would not be able to route traffic to 1. Now there's also the concept of forwarded traffic. Now forwarded traffic is basically traffic that comes from another source that it wants to get to new test 1. So let's say there's another peering relationship between new test 2 and new test 3, but traffic from 3 can get to 1, and then of course the other way around as well. Do we want peer traffic that comes from other networks to get to 2? We also have this concept of a gateway transit. So if we want to set up a network gateway, then this will allow us to go across the VPN if we want to connect into the corporate network or ExpressRoute. So that's it. We've set up a two-way communication between new test 1 and new test 2. We've enabled it in both directions, and right now we're not allowing traffic from other locations, and so I can say OK. And so now it's doing a dual deployment here. It's deploying the peering relationship on the one side and also the peering relationship on the other. So that's it. It basically set this up. We can see that the peerings now exist. If we were to go over to the new test 2 network, into peerings, we can see that that deployment succeeded as well. Now, setting up this peering is not the only determinant of whether these two networks can communicate. We're also going to be dealing with things like network security groups, which block traffic, certain types of traffic from traveling over the network, and also firewalls and other settings that are basically going to shape traffic or user-defined routes and other things. So just simply setting up these two networks allows them to understand the IP address range of the other network actually exists and how to get traffic there, but you still have security settings that could get in the way of stopping traffic from traveling, or at least determining what kind of traffic can go over that network. So right now we have two virtual networks that are set up to talk to each other over a peering relationship. So new test 1 and new test 2 can communicate with each other, and coincidentally they're both in the same region. But what happens when we have a virtual network that is halfway around the world in Japan? Can we set up a peering relationship with Japan? So I'm going to go into new test 3, which is in Japan, And I'm going to go down to peerings, and I'm going to add a peering. Now we're going to set this up to 3 to 1. So we're going to connect new test 3 to new test 1. And I'm going to select the virtual network. We can see new test 1 available from the drop down. And this is going to be called new test 1 to 3 because it's on the other end of the connection. For now, we're going to leave the default settings, so we'll allow two-way traffic and we won't have forwarded traffic. I'm going to click OK. Again, the deployments are made into new test 3 and to new test 1. Now, new test 2 is not affected. Also important to notice, nothing on the network is brought down, that there's no disruption to the existing systems. We're able to open up the communication, but we're not actually negatively reflecting the VMs or anything like that. Okay, so now we have very easily set up a connection between Japan and East US 2, so between 3 and 1. Now notice 3 can talk to 1 and 2 can talk to 1, but 2 cannot talk to 3. Now what can we do? We can obviously set up a pairing relationship between 3 and 2. So that's one of the options, is to make this into a triangle effectively, where every virtual network has 2 peers. The other option we have is to set up a chaining relationship. So we already have 3 talking to 1 and 1 talking to 2. So why couldn't 3 talk to 2 by traveling the traffic over 1? Well, it certainly could. When we were setting up our peering, I'm going to go into new test 1 and into peerings. Let's look at 1 to 2. We actually did not allow forwarded traffic. So if we enabled this setting, this would be allow forwarded traffic from 2 to 1. In actual fact, we want traffic from 1 to 2. So I guess I go into here, into peerings. So enable forwarded traffic from 1 to 2. So any traffic from 3 that wants to travel to 2, we can enable this in this section. Now we also do need to enable it on the reverse as well in order for 2 to talk to 3. So I'm going to save that, and we're going to go back into 1, into peerings, and we're going to enable traffic to travel from, I guess it's from 1 to 3. So we have to be very careful here with this, the wording. So allow forwarded traffic from 1 to 3, I can enable that. And now we have traffic traveling from 2 to 3 and from 3 to 2 with 1 in the middle. And that's a chaining relationship. It's also probably important to talk about the pricing, because although creating these virtual networks is free, so I created 3 virtual networks, all for free, and every subscription is allowed up to 50 virtual networks in total. Then we do have pricing for peering. So just having the 2 East US 2 regions virtual networks connected to each other, that is 1 cent per gigabyte in terms of traffic. You know, that's not that cheap actually, because storage is 2 cents per gigabyte for a whole month. And we're talking about data being 1 cent per gigabyte in a communication. So when you set up stuff in terms of peering, you're actually introducing bandwidth charges. Also important to notice, it charges on both ends. So you send traffic from VNet 1 to VNet 2, VNet 1 incurs 1 cent from the outbound, and VNet 2 incurs 1 cent on the inbound. So it's actually 2 cents for a single burst of traffic from one network to another. Now, if we're talking about global, so now we're outside of the region, then pricing is different, and it's also based on zones. So if we scroll down to the bottom, we can see there's a frequently asked questions, and it asks what is the different zones. So we were dealing with East US 2, and that was in zone 1, and we were talking about Japan, and that's in zone 2. So what we're talking about is data that's traveling between zone 1 and zone 2. So if we scroll back up, we can see under global VNet peering that we have a data transfer coming into the United States at 3.5 cents per gigabyte and traveling outbound at 9 cents per gigabyte to Japan. So we're looking at something like 12.5 cents in order for data to travel across those two zones. Okay. So it says if data is being transferred from zone 1 to zone 2, which is our exact scenario, then you're occurring outbound from zone 1 and inbound into zone 2. So it's about 12 cents a gigabyte, which is way more than the inter-region pricing. So that's something important to keep in mind when you're talking about transferring data across a peering relationship. And that's just the reality of it, I guess. Now, when it comes to allowing devices on these virtual networks to talk to each other, we've already seen how to set up a peering relationship, but there's also a second way to do this. That is using network gateways. So if we go into one of these virtual networks and we go into subnets, we can actually see that by default, we only have the one subnet. We'll talk in another part of this course about how to create other subnets for other purposes. But there's also this thing called a gateway subnet, in which we can install a network gateway. Network gateways set up site-to-site VPNs between 2 points. Now, normally this would be used as a VPN between your office and Azure. And so you can set up a VPN device, a physical device in your premises to connect to this network gateway and allow people on your network to talk to Azure and vice versa. Well, we can use these same network gateways to set up effectively a site-to-site connection between two VNets. We're going to go ahead and create a gateway subnet. Now, actually, before we do that, we should note that I have intentionally left some space on the VNet for these extra addresses. So the entire VNet is a /27, which has 32 IP addresses, but the subnet is a /28, which is only 16 addresses. And as you see, 5 of them are reserved, and so there's only 11. So we do have half of the address space available. So I'm going to create a gateway subnet. It's given a name that we have no control over, and it's automatically going to take the remaining 11 addresses for itself. We're not going to set up any security, anything like that. We're going to leave it as the default. So it's going to create a second subnet called gateway subnet on this thing. Now, in order to use this, we're going to have to add a network gateway to this as a virtual device. So I'm going to go back up to the resource group, say add. I'm going to type network gateway, and we can see virtual network gateway as a device. Now we have to give it a name, so VNet Gateway is a good name as any. Now it is important to where we're going to place it. We want this virtual network gateway to be in East US 2 because that's where our virtual network is. And then we'll put one in Japan and we can set up those two. This is a VPN device. We'll leave the defaults on that. And which virtual network are we going to add this to? Well, we only have the network gateway on new test 1 right now. Okay, so it's already picked up the gateway address range. If I had chosen new test 2, then it would have created me that address range for me. It's smart enough. Now it does network does require a public IP, so call this new gateway 1, new gate 1. I'm going to leave all these other defaults set, save, review, and create. And create. Now, while that's doing, I'm going to switch over to the pricing screen. Now, as you'd expect, virtual networks are not free. And so we're looking at basically getting a device like, I think we chose the Gateway 1 SKU, and so it is 19 cents per hour. That does add up to about $140 a month in this sort of SKU. Now we get a dedicated set of bandwidth, and we get up to 30 site-to-site tunnels that we can set up, which will allow us to connect to other virtual networks. Like I said, or set up to our on-premises. Okay. Now the pricing for traffic is different, and it's actually cheaper to do this network gateway connection than it is to do peering. But as you see, we're paying for the device itself. We'll be paying for devices on both ends. But you do get free inbound traffic, so you're not paying on both sides. You're only paying on one. And you're paying the regional rates for outbound traffic. So if you have a lot of traffic going from East US 2 into Japan, you're getting free inbound traffic in Japan, and you're only paying the 3.5 cents per gigabyte, which is the low-end price of traffic from East US 2. And so compared to the 12.5 cents we were looking at for peering, 3.5 cents is a lot cheaper. Now you're going to have to do the math and see if paying $100 a month for a gateway on both ends times 2 is cheaper than what you're actually paying for the data transfer bandwidth. So there's going to be a mathematical calculation to see if this is a money-saving method for you. Now, while we're waiting, I actually deployed the virtual network gateway to the Japan network as well. And so we are in the deployment process. Now, it does take a little while. So the virtual network gateway has been deploying now to East US 2 for more than 5 minutes. And so it's going to take 5 to 10 minutes for this network gateway to get started. And we'll pause the video and come back when that's set up. So it took 22 minutes to get a virtual network gateway deployed into East US 2 and 32 minutes to get that deployed into Japan. So now that those deployments are complete, we can take a look at them. So I'm going to go back up to the resource group level. Now, before I get into the gateways themselves, let's look at the networks. So remember, we added the gateway subnet to those two networks, new test 1 and new test 3 in my case. If we go into connected devices, we can see that the network gateway successfully connected to the gateway subnet in this network. Go back up to the resource level, and I'm going to go into that gateway. What we're interested in is connections, okay? Now, there are no current connections. Now, we could set up a point-to-site VPN or a site-to-site VPN, but in this case, we're going to set up a VNet to VNet connection. So under connections, I'm going to say add. We do have to give it a name. I'm going to call this Talking to Japan. It is a VNet to VNet configuration as opposed to site or ExpressRoute. So that is one of the valid VNet gateway configurations here. Now we know that the first gateway is the one that we're in, which is the VNet gateway. The other gateway is the Japan gateway, and we can choose this from the list here. So now we're signaling that we want to connect these two gateways. We do have to create a shared key that both gateways are going to have to be set up with in order to have this communication. Now, if we had a physical device, we could grab the key from that, but this is a VNet to VNet. So we do have to give it the password effectively. Now, it's not hidden in any way, so I'm going to put just my shared key. I'm going to leave all the rest of the defaults. We know what subscription we're in, what resource group we're in. We know where this gateway's already been created. So I'm going to say OK. We'll give that a moment to get created. So it's been about 10 minutes since I created this connection, and we can see that it's in a connecting state. If I go into it, we can click into it. We can see it's a connection, and it is connecting the new test 1 and new test 3 networks based on the two gateways. Remember, this is in East US 2 and this one's in Japan. And so we can go into activity log, and we can actually see that there's activities going on. 13 minutes ago I started this connection, and now we're into some other stuff. So we can actually look at the deployment as it's going. Oh, and now it says succeeded. So now we have, as we were clicking around, 2 virtual networks that are connected to each other over a network gateway. Now, so remember, we've got peering that can be local or global with one pricing structure, or we've got this network gateway, which can also be local or global. Now, the advantage of a network gateway over the other option in terms of peering is that network gateways are actually scalable. So if you have a lot of traffic being sent, you can actually get up to a higher skew. Like if we go into the configuration, we can see that we chose, gateway 1, but we can go into gateway 2 and gateway 3 if we wished. We can also set up an active to active configuration, which would allow even redundancy in case, so that this thing would even be higher availability. Okay. So gateways have sort of an enterprise grade to them, not saying that peering is unreliable in any way either. So we can also set up a configuration where you have your corporate network using a site-to-site VPN to get into Azure using a gateway, and then being able to then further connect onto other networks from there through a peering relationship. Now, we did set up a gateway on both ends, but that's not even required in a peering relationship. Remember when we were looking at the peering, I go into this one and into peering, we could have enabled, we basically could have enabled a network. We can enable new test 2 to use the VPN device on new test 1 or the gateway device for new test 1. And so this concept of remote gateways is a way of having one VPN device and then having remote gateways that are using that device to communicate onto the corporate network. So lots of sort of settings when you want to set up peering between different networks. So in this video, we're going to talk about VPNs or virtual private networks. Later on in the video, we're also going to talk about ExpressRoute. A virtual private network, as the name implies, is a connection between either your computer and a virtual network within Azure, or a whole network of computers and a virtual network within Azure. Now, VPNs certainly exist outside of Azure. You may be using a VPN for work right now, or you may have one installed at home, or you use a work laptop that requires you to connect to a VPN before you can do work. And so it's quite a common setup, and it's been that way for a while. Now, the advantage of this is you may have significant data, services, files, stuff within Azure, but you don't want that obviously to just be open and exposed to the world. And so you can imagine setting up resources within Azure, setting your firewall and NSG restrictions pretty tightly so that there's no outsiders allowed in. But you can use a virtual private network, which is pretty safe and secure, to connect into this device, and then you're exposed to those resources as if they were local to you. So that's the sort of the advantage of having a VPN, is basically using resources that are pretty remote securely. Now, the private part of a virtual private network means that the data between yourself and the remote network is encrypted. So it does travel over the public internet. So if you're working from home, even if you're working for your company from home, it is using your internet connection to your ISP. And so that's traveling encrypted, and nobody can read the data between you and the outside network. Now, in order to do that, there needs to be a encryption VPN client on your computer and a remote virtual network gateway in order to do the decryption. Now, within Azure, there's a couple of different options for VPNs. One's called a point-to-site VPN. The other is called a site-to-site VPN. We're also going to talk about ExpressRoute and finally ExpressRoute Direct, which are private connections, don't travel over the internet. So let's talk about point-to-site VPN first. We can see in this diagram that we have your computer, whether it's a laptop, your home computer, your office computer, that is sitting there, and it is able to travel, traffic is able to travel from that computer into Azure. privately and securely. In order to do that, you need a VPN client, software that's installed on that computer, and also a virtual network gateway that is remotely installed within Azure. You configure those things to work together securely, and then you're able to set up that connection. Now, this connection is temporary. You have to connect to it, do your work, and then disconnect from it. Typically, while you're using your computer, you can use the public internet. So you are actually using a different network to connect to the internet and a private network to connect to Azure. Some workplaces, if you're depending on the type of software that you're using, will restrict the access to the public internet while you're connected privately. It depends on how your software is configured. So in this case, you've got your computer. Now you can have multiple point-to-site VPNs. So you could have the VPN client, your coworker could have the VPN client, someone else has a VPN client. In fact, if you think about a workplace, anyone who works from home typically has a point-to-site VPN because they're not connecting all the devices on their home network. They're only connecting that individual device. So you can have multiple point-to-site VPNs, but it is not an efficient method for VPN. It's really good for one-time use. There is a temporariness to the connection, but it's not persistent, and having to log in every time you want to use something remotely is a bit of an inconvenience. And so the site-to-site VPN is perhaps the solution to that. If you can connect an entire Office network into Azure, all of those computers on the Office network can connect into the resources on Azure. They don't have to log in. It's persistent, it's not temporary, etc. Now, the cost there is you need a physical VPN device on your Office. So either you already have one and you can just set it up, or you need to acquire one. And Microsoft provides a list of the devices that they support, but it's pretty standard. So you do need a physical device within your Office. The device within Azure is a virtual device, as is most cloud services. So you just go in there, you configure it, you go into the marketplace, you can find a virtual network gateway, and then you can consider setting up either a point-to-site or site-to-site using this device. Now, site-to-site has additional features beyond point-to-site, and that is it supports redundancy. Now, when we're talking about availability of a solution, if you have applications running within your within your corporate network, and data and other things that are dependent running within Azure, well, that makes the connection between your company network and Azure more critical. And so having a single VPN device and a single gateway, a single connection, those are all single points of failure. Now, by default, Azure actually sets up double connections. So if you have a single device in your company and a single gateway, you're getting technically two connections between those two locations. So there is some redundancy. In case one of those connections fails, the other connection is still active. But they can go further. So you can have multiple devices. So if you do have multiple gateways within your company, you can set up multiple gateways and have that connect into the single virtual network gateway in Azure. On the opposite side, you can have your single gateway device in your company connect to multiple virtual network gateways. And finally, for the most redundancy, you can have multiple gateway devices and multiple network gateways connecting to each other. That way, if any of these devices fail, then your connection continues, and whatever vital service that runs between your Office and Azure continues. Now, site-to-site is great for most circumstances, but it does run over the public internet. There is some speed restrictions, and of course, if you might need to get faster speeds and lower latency, and maybe the fact it runs over the public internet is a concern, so there's a security concern. Microsoft provides a thing called ExpressRoute. ExpressRoute is a private connection between your location and Azure using an IXP, an exchange provider. Okay, so you're still encrypted, but it's also running over a private fiber, private connection. You do need to work with a private communications provider to set it up. In the case of ExpressRoute, there's a middleman. But basically, it's a faster connection There's some more cost to it. If you've got a lot of traffic traveling between those two locations, then it might be the better solution. Now, we're looking at ExpressRoute. There's actually a couple, what Microsoft calls peering. So depending on the service that you're connecting to, you're going to run over a different network. If you're connecting to like Outlook, Office 365, the Azure portal, Dynamics, whatever, public service that you're connecting to, well, that's called Microsoft peering. And that'll run out to a DMZ or an external network in order to connect to Microsoft. But for private peering, when you've got, VPNs and virtual networks and virtual machines and databases running within that's over a private peer, and that'll connect your devices themselves and the networks themselves privately, not over the DMZ. There's various pricing. You can go between $55 a month to $5,000 a month, but you're going to pay for traffic. If you're willing to get unlimited traffic, that costs more, of course, and that runs between $300 a month and $50,000 a month. So let's talk about a relatively new feature of Azure ExpressRoute that's called ExpressRoute Direct. Now, ExpressRoute requires you to go through an internet service provider to connect to the Azure network. But through ExpressRoute Direct, you can actually connect directly with Microsoft to apply to connect directly to their global Microsoft backbone. Microsoft currently has around 150 edge locations around the world. That's outside of the regions that they have, virtual machines hosted. And so if you're close to one of those 150 edge locations, you can just get your servers directly onto the Microsoft network through ExpressRoute Direct. One of the advantages, of course, is you're going to get even higher speeds. So instead of having to go through an internet exchange provider to get your computer servers onto the Azure network, you go directly to Microsoft and it gets you some blazing speeds. So the two speeds available for ExpressRoute Direct are the 10 gigabits per second and 100 gigabits per second. Obviously, that's a huge jump, and 100 gigabits per second is a massive amount of speed. Now, the way this is provisioned is slightly different. When you go through regular ExpressRoute, you're getting a circuit, what's called an ExpressRoute circuit, at a provisioned speed. So if you've got a 1 gigabit per second ExpressRoute circuit, that's the single circuit, and that's the speed that you got. With the ExpressRoute Direct, you're provisioning 10 gigabits or 100 gigabits per second, and you get to build up multiple circuits. So within that 10 gigabits per second, theoretically you could get a single 5 gigabits per second, a couple of 2 gigabits per second, and a 1 gigabit per second. Take those 4 lines together to build up to your 10 gigabits per second, and you end up with 4 circuits. That means you can connect them to different networks for different purposes. For the 100 gigabits per second, you can take that 100 gigabits directly in a single circuit, or you can put in some multiple 10 gigabit per second circuits in there, etc. Now, why do you need 100 gigabits per second? Well, the most obvious answer is for those situations where you have massive data ingestion requirements into Azure. So let's say that you have a massive data lake sitting within Microsoft Azure. You've got some big data services running that is processing data in your data lake, and you need that data to be flowing from your network into Azure, and you need that 100 gigabits per second connection to get all that data in there. Well, that would be one example of what you would use an ExpressRoute Direct for. Now, do keep in mind that the 100 gigabits per second might sound great, but that's very specialized network hardware. The 100 gigabit per second standard for the internet only came about less than 10 years ago, and so you're going to need to have hardware that connects, to get onto this 100 gigabits per second network that operates at those speeds. The same is for the 10 gigabits per second circuits as well. you have to have a 10 gigabit per second circuit in your network internally in order to connect to that speed. So otherwise, it's no point to doing that. Now, this question has come up before, where people would like to connect their two branch offices to each other using Azure. Once they find out that you can set up a site-to-site VPN or an ExpressRoute VPN, they wonder if they can do inter-office connectivity through Azure. The answer is actually yes. Microsoft provides this virtual WAN service, which allows you to connect two endpoints to each other. If I flip over to the documentation, we can see here that it's only 25 cents an hour in order to have the hub running within Azure itself. And then you're going to pay for connecting a site-to-site VPN or a point-to-site VPN or an ExpressRoute into that hub. So if you've got a Toronto office, a New York office, and a London office, and one of them is running on ExpressRoute and two of them are running on site-to-site VPNs, then you're adding an additional 15 cents an hour on top of that 25 cents. So it's a very affordable way for you to connect your offices as long as they're connected into Azure.